there's one more thing that can definitely help us out a lot down the road, and that's going to be error handling. So we've seen in the past kind of videos that sometimes errors just pop up. And usually when you're starting off and you're making simple programs, errors are usually kind of the programmer's fault. So like you forgot something, or something goes wrong, you didn't account for a certain situation. But other times, when you're going on, it could eventually not be your fault anymore. It could be kind of unavoidable things. For example, if you're importing big data tables and you're expecting numbers, but sometimes there's a not available, but you're trying to turn all the numbers from strings into floats. So for example, I'm importing a big data table and I get the number 123.4, for example. And every time I get a number, I just directly turn that into a float. So I go float of that number to make it a float, and then I'm going to get the number 123.4. So this all works fine. Now, there may be a float and it's going to say something like NA, so like not available. Now, this is just one of the numbers I'm going to get, and either I have to account for the situation, or this is going to give me an error. So this is, if I don't especially account for the situation, it's going to give me an error. And it could sometimes be, that you don't just have an NA in there, but you have a lot of different things, that you can't all take care of. You can't just account for every special situation. So what you can do is, instead of trying to say like if this or if that or blah, 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 you can just use error handling. And you can say, let's try to turn this into a float. And if we can, great. If not, we'll deal with that when we get there. So everything that's going to be able to get turned into a float, we're going to do that. Otherwise, we'll just do something else with it, and we'll get there when we get there. So this is kind of the idea of error handling, that sometimes you may get stuff that's unexpected, or sometimes, for example, if you ask for user input, you can either try to cover all situations, or you can just, try, so error handle the input. And if you forgot to check for one situation, you can just, print back to the user, well, something went wrong with your input, please try again. And you can even tell them the error, for example. But that just kind of helps you manage, all these kind of flows and logic statements and, checking for everything. This error handling becomes really, really great for that. So we'll just see a couple of examples of that because it's really nice, It helps you get through a lot of stuff. It also helps you with debugging too. So yeah, let's just get into it. And so the first thing, or the way that we would approach it, error handling, is something called try, and the counterpart of it is an except. So this really means what what it says. Oh, maybe let's just comment this out on the top here so that we don't get any complaints from here. So what this means is try. So let's just try the following code. If it works, great. If not, then we enter the except. So it's almost like an if and else statement. But here we have now a try, so we're going to try the following. If it works, great, let's move on. If it doesn't work, we're going to enter this exception. So we're going to go except. So for example, let's try to print hello. And if we get an exception, we can just say print and then entered exception like this, and maybe lowercase. But yeah, so what we're doing is we're going to try to print hello. If it works, we're going to print it. If it doesn't, we're going to enter this. So let's see that in action. So now we see we print hello. And since we printed hello, we don't enter the exception. Let's make this mess up. So let's try to print the integer version of hello. And if we run this now we see, instead of getting an error, and instead of our code stopping, we just see entered exception. And our code technically still goes on. So for example, if we print here past exception, like this, so we have the try and we try to do this, and then otherwise we have this exception. And just to show you that the code actually goes on afterwards, we're going to have this past exception statement. And we're going to see here now we entered the exception, and now we're past the exception. So now our code doesn't stop when we run into an error, it just keeps going. And it does something special with the error. So another thing that you can do, for example, that's special to errors is something that you can try is you can try to make an integer version. So let's say we have the example above. So our keyword, let's create a keyword, and this is going to be, well, let's just start off with 1, 2, 3. So our keyword is going to be 1, 2, 3. And what we're going to try to do is we're going to try to print the integer version of our keyword, like this. And so sometimes we're going to make it work and other times not. And so, for example, so this is kind of similar to the reading in of data, but this is kind of a simplified version. So if we run this, we see now, well, we try to print the integer version of the keyword, which works. So we get 1, 2, 3. And we don't enter the exception, and now we're past the exception. Now if we try to, if our keyword is hello, and we try to print the integer version of that, we enter the exception, and then we go past the exception. Now something that we can do too, rather than doing something in the exception, we can also just not do anything. So the keyword for that would be pass. So what does that mean? So we have this try statement, and then we try to print the integer version of our keyword. If it works, great. If it doesn't, we're going to enter the exception. And now what do we do in the exception? Well, we pass. So what does that mean? Well, it means we don't do anything. So what this code is kind of doing is it's going to try to turn it into an integer. If it works, great, it's going to print it. If it doesn't work, it's not going to do anything. It's just going to skip it. It's just going to pretend it never happened. So either it's going to try to print the integer version of it, or it's just going to say, well, let's just move on then. Let's not worry about that. So that was something that didn't work, and I'm not going to be bothered with that anymore. So as we see here, if I run this, now I pass. So I don't do anything anymore. And if I put something afterwards, for example, if I print here, entered exception, like I had before, but it's after the pass statement. So similar to like if statements and loops and functions and everything else, if you have these colons here, everything that's beneath it that's indented is part of this statement. So everything, I can add more lines here, they all have to be indented. And just like here, I can also add more lines, they just all have to be indented. So if I run here and I pass, so well, technically I'm passing, but I still get this enter exception. So it's not a break, it's just a pass. So if I take this away again, for example, then we see nothing happens. So I don't actually have to put anything in here. I don't have to do anything. I can just use this pass keyword, which just means don't do anything. We're just going to leave it. And that's the reason that you kind of need this keyword is that you can't just leave something empty like this. So leaving something empty like this is going to give you an error, actually. So that's because if you put these colons here, you need something here. Python expects something to come. And now it's telling us this should be indented because it needs something to come here. And so it's telling us, well, the next thing that comes is this, but this isn't indented. And I need something to be in here, so this needs to be indented for this to work. So you can't just leave something blank, and that's why you have this pass keyword, so that you can put pretty much nothing inside. Yeah, so that's what we kind of see here. Yeah, so this is the try and accept. Something that you can also do is you can actually catch the error. So what we can do is we can try this, and then what we can get is we can say, well, accept, and we're going to catch this exception. And we're going to store this exception, and usually we'll just store it as E, so as the exception. And then let's just print the string version of E, just to be sure. Usually it should be string anyway, but you know, sometimes you run into some kind of problem somewhere. So just to be sure, we're gonna print the string version of the exception. So let's run this, and then let's see what we get. So we see here, we try to print the integer version of hello, doesn't work. We go into accept. Now what we do here is we accept, and what we do is we kind of catch this exception. So this try here gives us back an error, or an exception, and we save that in E. So we take this exception and we store it in E, and then we print the string version of it. And so the exception that we have right now is that the invalid literal for int with base 10, hello, pretty much means I can't convert int. I can't convert hello to an int. So that's what it's telling us in fancy computer talk. And then we go past the exception and we go on with our lives. So that's kind of a way that you can kind of take hold of these exceptions. So something else that you can do is you can accept specific errors. So if you're expecting different types of errors and you want to respond to them differently, you can have several except statements. So for example, if, well, let's just print out the integer version of hello, of our keyword, and before even this try statement, just to get an error. And we see here we get something called a value error. So this is, for example, one of the errors that we can have a special case for. So for example, we can go in here and we can say except, and then instead of having just, either exception is E, so catching anything, or just, whenever, what we're going to do is we're going to accept a value error. So specifically when this type of error is raised, and now there are many types of errors, so this is just one of them. Specifically when this type is raised, let's just print out got a value error, like this. So that's something that we can do. And if we run this, we see we're still running this, so we get the error from before. If we run this, we shouldn't get any error output. We should get the output that says we got a value error, but our program shouldn't crash like it did up here. So we see except, and we got a value error. And so we handle that appropriately, and now we say we'll print value error, just like that. Yeah, so we can have special exceptions here. We can also have another except here. So this is just going to be in case there's a value error. Then we kind of print it. So if this is kind of a special error, then we print it. Otherwise, we print other type of exception, like this. So yeah. So I mean, if we run this again, we're always going to get a value error here. So we're always going to print out that we've got a value error. But in case anything else pops up here, we should kind of be covered. So yeah, this is, you can just kind of add except statements on. You can check for special kind of except situations, and then kind of go on. Kind of like, it's really kind of like if and else statements. You just have to make sure they're not interrupted in any way. So an except always has to follow a try, and then except can follow an except again, and stuff like that. But you're not allowed to have like an if statement in between here or something, or like a while loop or anything like that. They just have to kind of follow each other one by one. So that's how these exceptions work in this try. And something else that we can also add is, so there's another keyword. So just like in if, we also have the elif and the else. In try and except, we also have something called a finally, like this. So, and what we can do here is we can just print finally. And so what this does is, no matter what happens up here, this is always going to be executed. So at the very end, this is always going to be called. So we're going to do everything we do up here, and then finally we're going to do this. So let's see that in action. So we see we try something and we get an error. Well, we get a value error, so we print got a value error, and now we do the finally, and now we're past the exception. So this finally is kind of like, well, we do all our error handling up here, and we check for special errors, and we do certain things, and then finally at the very end we do this. So that's how this try except finally works. Yeah, so maybe also to show you, so there is another thing that I wanted to show you, and that's called raising an exception, or raising an error. And we can actually try now to skip this value error. So what we can do is, instead of printing something, we can manually raise an error. So rather than typing something wrong like we had with this print and keyword, we can raise a value error, for example. And now what this does is, even if your code succeeds, or if it would have succeeded, you're telling, you're kind of going through the program and saying, well, I got an error. But your program may not be the one that's saying I got an error. You're the one saying I got an error. And so this may be, for example, if you're checking for specific situations, and even though they're different types of errors, but you want to handle them the same way, then you can raise a value, or you can raise not just a value error, but any type of error really. But this just kind of lets you define yourself what you want the error to be, rather than having the computer tell you what it wants. So if we run this, for example, and we try, and what we do is we raise a value error, then we print we got a value error. Now let's say if we don't raise a value error, but if we raise something like a name error, so this is just another one of those error names, and like I said before, you'll see these errors down here. If your code ever goes wrong, you'll just see a bunch of these errors here. Where else do we have one? We got a bunch of value errors, but there are other types of errors depending on what you're doing. So now we're going to raise a name error, and what we're going to see is we're actually not going to go into this value error, because so what we do is we try something, and what we do is we raise a name error. And so since we raised an error, we're going to catch it in one of these exceptions. And it's not a value error, so we're not printing got a value error here. It's a name error. And so that falls in our other type of exception here. And so we print we got another type of an exception. And then finally we just print finally, and then we're past the exception like this. So this is we can just kind of manually raise errors here. And if we kind of want our program to stop, so what we can do is we can raise the error in the try, and then we can actually raise it again afterwards. So if we run this now, then what we see here is, well, first we try, and what do we try is, well, we raise a name error. So we're trying to raise a name error, and we do that successfully because we're just raising an error. And now this error is going to get caught by one of these exceptions. And it's not going to get caught by this value error exception because it's a name error. So it's not going to print got a value error, but it is going to be caught by this except. And so we're going to print another type of exception. So that's what happens first. Then we execute the finally. So we print finally, and then we actually get this raising of this error that we have here. So what we see is, well, our program crashed because we manually told it to crash. And it's because we raised a name error, like this. And so we see, like before, we had value error and a bunch of descriptions, and it's telling us where it went wrong. Same thing here, it's telling us where we went wrong. We went wrong in line 11, which is here. That's where we raised our error. And what we raised is just a name error. And so that's what we see here. So we can kind of manually crash our programs too if we want. We don't just have to rely on the computer to do that. And so, for example, if we take this away again, then our program's not going to crash. But if we leave it there, then we're actually going to raise the error again, and then it's going to crash, just like that. Yeah, so error handling may look a little bit weird first. And maybe what we can do is we can also just kind of catch the exception again as E, because you're going to be catching exceptions a lot because you want to know what went wrong. And so instead of raising the error, let's print the string of the error. So we're getting this error back, or this exception back, and we're catching it. So that's what you're kind of doing. You're trying, and then you raise an error, and then you kind of catch it through an except statement. And now we kind of save this except statement, or this exception in E, and so we can print it, and so that we can actually see what went wrong. And so if we run this, we see, well, we actually don't see anything because we didn't put anything in here. So what we can do is we can raise the name error and say error, just like this. And so if you run it now, then we see this is kind of the message delivered with the error. So the message delivered with the error in this case is error. If I change this to error 1, for example, the message is going to be delivered as error 1. If I once again here try to print the integer version of our keyword, which is still hello, and well, maybe I don't have this because it's going to be in value error, but we actually want to catch it. So we're going to see here we get another type of exception just because we commented this out, and we catch this exception as E, so we kind of store it in E, and then we print out the string version of E after the other type of exception, and so we print out the error here, but we don't stop our program. And so this kind of lets us continue to run our program, but all the errors are printed to the screen, and so we can kind of see what went wrong without distributing without disturbing the rest of the program flow. And so this is all going to be really helpful later when your code or your data especially becomes kind of complicated, and sometimes it may mess up, but you don't want your program to crash the whole time, or because you don't want to go in manually, or you don't want a bunch of except statements. So you're just going to try to do everything, and in case something goes wrong, you can just ignore it, and you can print the error to the screen to kind of know what went wrong, and you can think about then, should I worry about it? Like, if it's an not available statement, then you're going to say, well, I'm not going to really worry about that. So if it says, the error is a value error or something, and then you print out, I got an NA or something, then that's fine. You don't want to do anything about that. But if you say, for example, oh, I couldn't convert a number here, and it's because the number format is different in one of the data files, then that's an important thing to know. So then you can kind of change the format there, or you can account for a different format or something. So it's generally nice to have these try and except statements, because there may be a lot of unexpected things that happen when you get in data, or when you deal with outside things, or when you write complicated code. Sometimes errors may just happen, and so this kind of lets you continue to run your program but skip over all the errors, and you can kind of see what went wrong. And it's really nice to just not have your program crash the whole time, and parts of it could work, and you can try to kind of fix the rest of the things as they happen. So like, you can see an error, and then you can decide, do I want to deal with this error or not? So this try and except, finally, maybe not that often, but definitely the try and except the whole time. You can put in a finally if you need it, otherwise you don't need to put it in. But this try and except is a really great kind of method, and it becomes very, very helpful later on. So this is just kind of one of those short introductions. We'll probably be seeing more of these try and excepts later. So if the syntax is still a little bit weird right now, don't worry about it. We'll see it more often. It's going to become a lot more natural.